Welcome back to Tech Margadarshi. In part 7 of our Java series, we'll explore important real world concepts like file handling, packages, methods, static and non static members, and wrapper classes. These topics will help you understand how Java applications are structured and used in real projects. Let's continue our Java journey and level up your programming skills. Here is the first topic of part 7: file handling in Java. File handling in Java is used to read data from files and write data into files. It helps us store information permanently, even after the program stops running. Java provides built in classes like file, file reader, and file writer to perform read and write operations easily. File handling is mainly used when we work with external data such as text files, logs, or configuration files, making programs more practical and real world. In this slide, we are learning how to create a file in Java using the file class. Java provides the java.io.file class to represent a file or directory in the system. Now let's understand the code step by step. First, we import the file and IO exception classes from the java.io package. The file class is used to create and manage files. An IO exception handles input-output errors. Inside the main method, we create a file object by passing the file name sample.txt. This does not create the file immediately. It only creates a reference. Next, we call the create new file method. If the file does not exist, Java creates the file and returns true. If the file already exists, it returns false. Based on the returned value, we print whether the file was created successfully or already exists. This is one of the simplest and most commonly used ways to create a file in Java. Now, write to file. First, we import file writer and IO exception from the java.io package. The file writer class is used to write text data into a file. Inside the main method, we create a file writer object and pass the file name sample.txt. If the file does not exist, Java automatically creates it. If the file exists, the old content will be overwritten. Next, we use the write method to write text into the file. After writing, we call close to save the data and release system resources. Finally, a message is printed to confirm that the data was written successfully. Now, read file. To read data from a file, we use the file reader class. It reads the file content character by character. We create a file reader object by passing the file name. Then we use a while loop to read each character using the read method. The read method returns the adi value of the character, or -1, when the end of the file is reached. Each character is typecast to char and printed on the console. Finally, we close the reader to free resources. Now, read file using scanner. The scanner class is a very convenient way to read files line by line. It is commonly used when working with text files and user-friendly input. First, we import the file class and the scanner class. Inside the main method, we create a file object that points to sample.txt. Next, we create a scanner object and pass the file to it. The method has next line, checks whether the file has more lines to read. Using a while loop, we call next line to read and print each line of the file. Once all lines are read, we close the scanner to release system resources. This method is easy to read, clean, and preferred when working with text-based files. Now, delete file explanation. To delete a file in Java, we use the file class. We create a file object by passing the file name or file path. The delete method attempts to remove the file from the system. If the file is successfully deleted, it returns true. If the file does not exist or cannot be deleted, it returns false. Based on the return value, we print a success or failure message on the console. Now, here is the next topic. In this slide, we are learning about packages in Java and their types. A package is a group of related classes and interfaces that helps organize Java code in a clean and structured way. Packages are very important when working on large applications as they make the project easier to manage and maintain. Java has two types of packages: built in packages and user defined packages. First, let's talk about built in packages. These are packages already provided by the Java API, such as java.util, java.lang, and java.io. They contain ready to use classes like ArrayList, scanner, and file. We don't need to create these packages. We just import them using the import keyword and start using the classes. In the example shown, we import java.util.ArrayList and use it to store and print values. This saves development time and improves code reusability. Next, we have user defined packages. These are packages created by programmers to group related classes of their own application. User defined packages improve code organization, avoid class name conflicts, and make projects easier to maintain. In the example, we create a package using the package keyword and place a class inside it. This class can later be reused in other programs by importing the package. So, whether it's built in or user defined, packages help write cleaner, modular, and professional Java code. Understanding packages is a key step toward building real world Java applications. Now, here is the next topic. In this slide, we are learning about methods in Java. A method is a block of code that performs a specific task. Instead of writing the same logic again and again, we place it inside a method and reuse it whenever needed. Methods help in code reusability, which means we can call the same method multiple times. They also reduce code duplication and make programs more modular and readable. A method can either return a value or be void, depending on the requirement. Now let's understand the code example shown. Here, we have a class named demo. Inside this class, there is a method called greet. This method does not return anything, so it uses the void keyword. When the greet method is called, it simply prints hello Java. Inside the main method, we create an object of the demo class using demod equals new demo. Then we call the method using the object d.greet. As soon as the method is called, the code inside the greet method gets executed and prints the message. So methods allow us to organize our code better, avoid repetition, and make Java programs easier to understand and maintain. They are one of the most important building blocks in Java programming. Now let's move to the next topic. In this slide, we are learning about static and non-static members in Java. First, let's understand static members. Static members belong to the class, not to any specific object. This means memory for static variables is allocated only once, and the same value is shared by all objects of that class. That's why static members are commonly used for common data, such as constants or counters. Now look at the first code example. Here, we have a class named test with a static variable called count. Inside the main method, we access this variable using the class name like this, test.count. This shows that static members do not require an object to be accessed. Next, let's understand non-static members. Non-static members belong to objects of the class, not the class itself. Each object gets its own separate copy of non-static variables. They are used to store object-specific data. In the second code example, the class test has a non-static variable called value. To access it, we first create an object using test t equals new test. Then we access the variable using the object reference, t.value. This clearly shows the difference. Static members are accessed using the class name, while non static members are accessed using an object. Understanding static and non static members is very important for writing efficient and well structured Java programs. Now, here is the last topic. In this slide, we are learning about wrapper classes in Java. Wrapper classes are used to convert primitive data types into objects. Java provides wrapper classes for all primitive types. For example, int to integer, double to double, char to character, and so on. Why do we need wrapper classes? Because many Java features such as collections framework work only with objects, not primitive data types. Wrapper classes allow primitive values to be treated as objects when required. Now we'll see in detail wrapper classes. Conversion examples. First, let's look at int and integer conversion. Here, a primitive int value is automatically converted into an integer object. This process is called auto boxing. When the integer object is converted back into a primitive int, it is called unboxing. Java performs both of these automatically, which helps in writing clean and readable code. Next is string to int conversion. In this example, a numeric string is converted into a primitive int using integer.parseInt. This is commonly used when taking input from users because input is usually received as a string. After conversion, arithmetic operations work normally, which is why the result becomes 120. Now let's see int to string conversion. Here, the integer value is converted into a string using string.valueOf. Once the value becomes a string, concatenation happens instead of addition. That's why 50 plus 10 becomes 5010. Next is string to integer conversion. In this example, a string is converted directly into an integer object using integer.valueOf. This is especially useful when working with collections like ArrayList, which store objects, not primitive values. Now let's move to double and double conversion. Just like int and integer, Java supports auto boxing and unboxing for double and double. The primitive double value is automatically converted into a double object and back when needed. This is commonly used in calculations involving decimal values. Next is string to double conversion. Here, a string containing decimal values is converted into a primitive double using double dot pass double. This is very useful when working with prices, percentages, or measurement values. Now let's see char and character conversion. A primitive char is converted into a character object using autoboxing and then converted back using unboxing. This follows the same concept as other wrapper classes. Finally, we have string to boolean or boolean conversion. In this example, the string value true is converted into a primitive boolean using boolean parse boolean. Java then automatically converts it into a boolean object through autoboxing. This type of conversion is commonly used in configuration settings and feature toggles. That brings us to the end of part 7 here on Tech Margadarshi. Today we learned how Java handles files, organizes code using packages, works with methods, static and non-static members, and wrapper classes. These concepts are very important for building real-world Java applications. Practice the examples shown to gain confidence. Stay connected with Tech Margadarshi for the next part of our Java learning series.